Hello everyone, welcome to another interesting video by Simplilearn. What is one of the most important and core concepts of statistics that enable us to do predictive modeling, and yet it is often confused by aspiring data scientists? Yes, I am talking about the Central Limit Theorem. So in this video, we will discuss all there is to know about the Central Limit Theorem. So let's start by discussing the agenda for today. We'll start with the definition of Central Limit Theorem and then discuss the mean and standard deviation associated with it. Then we'll take a real life example to understand where you can use the Central Limit Theorem. Then we'll discuss some assumptions that are taken for effective use of Central Limit Theorem. We'll end this tutorial with a demonstration of the Central Limit Theorem in Python. So without further ado, let's get started. So what is the Central Limit Theorem? The Central Limit Theorem is a statistical concept that states that the sample means of the distribution of a random variable will approach to a normal distribution if the sample sizes are large, respective of the shape of the original population distribution. We take the population and we take the sample out of them. Let's discuss the mean and standard deviation associated with it. Suppose we are sampling from a population with mean mu and a standard deviation sigma. Let x be the random variable representing the sample mean of n independently drawn observations. Then we can say that the mean of the sampling distribution of the sample means is equal to the population mean, which is mu x bar is equal to mu, where mu x bar represents the mean of the sample means and mu represents the population mean. On the other hand, the standard deviation of the sampling distribution will be equal to the population of the total standard deviation upon the under root of sample size. Let's understand this more clearly by taking a real world example. Suppose you are a regional manager of a pharmaceutical company in charge of 200 stores across the region, and you are in charge of weekly medicine restocking at all of them. You need to know how many cases to order weekly for each store in order to reduce the amount of inventory that expires. The plot on the right hand side shows the distribution of all the 200 stores and the average medicine cases required by each of the stores in a week. The red line represents the average cases required, which is equal to 34. You know, there has to be a better way to arrive at a reasonable answer that doesn't entail visiting every single store in your area and obtaining their weekly sales figure. You can apply the Central Limit Theorem to this problem now that you understand the concept. We already knew the Central Limit Theorem, when applied to real world problems, aids in balancing the time and cost of gathering the data required to draw the conclusions about the data. So here you can see the plot on the right hand side shows the distribution of sample means of the sufficiently large subsets taken from the population. Sample size greater than 30 will be sufficient enough to get the normal bell curve. The mean of all the samples taken from that population mean is equal to 34, which is equal to the sample mean of the subsets. If you plot the sample means, you will get a normal distribution which is a form for bell curve. If these samples meet the Central Limit Theorem criteria, you can assume the distribution of the sample means can be approximated to the normal distribution. Now you know how to apply the Central Limit Theorem in a real world problem. Let's discuss some assumptions behind the Central Limit Theorem. The first one is the randomization condition. The data must be sampled at randomly and it must adhere to the randomization rule. The second one is the independence assumption. The sample value must be independent of each other. This means that the occurrence of one event has no influence on the next event. Usually, if we know that people or items were selected randomly, we can assume that the independence assumption is met. The third and the last one is the 10% condition. This states that when the sample is drawn without replacement, the sample size, which is n, should be no more than the 10% of the population. Let's now discuss some application of the Central Limit Theorem. Political and election polling is a great example to show how you can use the Central Limit Theorem. These post results are used to estimate the number of people who support a specific candidate. To calculate the confidence interval, which is shown on the news channel, the Central Limit Theorem is very useful in this. One more place where you can use the Central Limit Theorem is the census data. You use the Central Limit Theorem to calculate the various population details such as family income, electricity, consumption, individual salaries, and so on. Now that we have a good understanding of the Central Limit Theorem, its theories and application, let's see a demo in Python to understand it more clearly. Here we are on an online compiler. We'll discuss the CLT by taking a dice example. A dice has a different number on each side, ranging from 1 to 6. Each number has a 1 in 6 chances of appearing on a roll. Given all the equal likelihood, the dispersion of the numbers that come up from the dice roll is uniform. Let's start by importing some necessary libraries. We'll import the numpy first. From numpy.random, we'll import the randit function, which will be used to generate the random integers. We'll also import the mean function from the numpy. We'll set the seed to 1. Now we'll write the function to generate the random numbers. The randit function will generate a number ranging from 1 to 6. We have taken the 100 because the example will print the samples of 100 dice rows along with the mean. Print the rows and then we'll print the mean of the rows. So when you run this code, we'll get the following result. You see, we have the 100 numbers and the mean of this number is 3.38. Now we'll repeat the process 1000 times. This will give you the result of 1000 sample means. According to the CLT, the result of the sample means will be Gaussian. So we'll change this code from here. Means will be equal to mean of this random integers. We'll take from 1, 7, 100 and this will be for in range of 1000. Now we'll plot this distribution. We'll use the pyplot function. We'll get the graph as a histogram graph. So we'll plot it in that means and pyplot.show. Let's recheck our code. We have the random integer function. We have the seed. Okay, we have imported the mean. We have not imported the matplot library. So from matplot library, we'll import pyplot. Now I think everything is in place. And let's try to run this code. Yep, you can see this graph is a histogram graph in the shape of a bell curve. And if you see closely, the mean is closely to 3.4. So that's it for this tutorial. Thank you for being here and watch out for more videos from us. If you have any doubts and queries regarding the central limit theorem, you can post it in the comment section. Until then, keep learning and stay tuned to Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.